In this lesson, we'll learn how to create a distributed design. After completing this lesson, you'll be able to insert a component, use Move Copy, and use a mirror feature. With some basic edits done to the initial design, it's now time to start making a more distributed design and bring in our components. We want to make sure that the top level of our file is going to be active. Now this means that anything that we bring in is going to be under this top level, not going to make any subcomponents under X star or any of the motors. We don't really need to see these right now, but I'm going to go ahead and make sure that all four of these are in the file. And you'll notice because we got rid of that carbon fiber material that these have all taken their original appearances. I'm going to expand my data panel, and I'm going to go into the components folder I created, and I want to start bringing these components in. Now at this stage, some are going to be more critical than others, and we will talk about all of these in specifics as well as some generalities. But I want to first start by bringing in my micro CC3D flight controller. So we're going to drag this in and drop it into the canvas area. Now once we do that, it's going to be the same process as when we inserted the DYS motors. It's going to come in, it's going to automatically open up Move Copy, and if we go to a top view, it's already centered on the origin. We want to go to a front view and notice that it puts it at the bottom of our file. Now this is because this is where our origin is located, where our top plane is. So we need to move it into a good location where we want its final mounting to be. Now you will remember when we talked about this initially in our course that the flight controller works best if it's on the center of rotation of the craft. Now this means in our case we have a perfect X design. So the center of our craft, or the center location between all the motors, is right here where we've drawn this X shape into the body. So this makes it real easy for us to find that location. Just leave it exactly where it is in terms of its X and Z positioning, and we simply want to adjust it in the Y. So as we look at it, we're going to drag this up, and we're going to pull it close to the upper edge of the body. Now we will be working on this design by adding a secondary piece that holds all the components. And the reason that we're doing this is because this allows us to assemble everything and wire everything as a unit, with the exception of the motors. They obviously will have to be bolted to this portion of the frame, but it'll make the assembly process that much easier. So it doesn't have to be in its final location at this point, but we want to make sure that we get it pretty close so that we can account for that area, that volume that we need to take up. So next, let's rotate this around and note that we have an arrow on the design. All right, so the CC3D or any of the flight controllers are going to have a direction they want to go. So we're going to have to rotate this around 180 degrees, and we can say OK. Now the reason that direction is important is because the controller needs to know which direction is forward and backward when it's flying, but it also affects us because all of our connection points are going to be on the back section. So let's go ahead and fit to screen, save our file, but we will be adding a few more components. The next thing that I want to insert here is going to be my HK-TR6A receiver. Now this is actually what gets the signal from the ground station or from the person with the controller. And the reason this is important is because most of these wires go directly to our flight controller. We have one flight controller wire that goes down to our power distribution board to power it up. But everything else from there is going to be servo control for the camera or something directly from the receiver. So the receiver is going to have multiple cables, and it plugs into the side of our flight controller. Let's go ahead and drag and drop this in, and again follow the same process. If we rotate this around to a front view, again it's placed at the same location, but in our case this doesn't have to stay in this location. We're going to go ahead and move it backwards, go to a front view, move it up a bit. Now again, we don't have to have it in its final location. We just want to get it somewhere that we can account for it. Now in our case, the small wire here is actually where the antenna cable comes out, and the black blocks on the top are where all the individual cables are going to come out for the multiple channels on the receiver. So that means that when we have a throttle or if we pitch or yaw on the craft, what we're going to do is we're actually going to be sending a signal that tells the flight controller which thing we're adjusting. So I'm going to rotate this around 180 degrees so that the wire that is our antenna faces out the back and we can zip tie it or attach it to the frame. I'm going to go ahead and pull this up just a little bit. And again, we don't have to have it in its final location, just want to get it close for now so we can account for that. We're going to carry on inserting other components. And next, we're going to use the batteries because they're going to be a large portion of the mass, and it's going to be important that we have the space for them and we locate them appropriately. So the batteries will come in, and if we look at these, you can see where the power wires are coming out. We're going to rotate this 90 degrees, and I want to move it off to the side. I'd like to have these mirrored across the midline. Now if I zoom out a little bit, might not be instantly easy to tell. Maybe if we go to a bottom view we can tell a little bit better. But the battery is centered on the origin as well. We moved it off to the right in the X direction, but we are centered in Z, and this is going to be important to make sure that the overall balance of our craft is good, because these are going to be 50 to 65% of the overall mass. They're going to make the most impact or the most critical change if we move them forward or backward into how this thing flies. So we want to make sure that we keep it at a good location. When we look at it from the front, we want to make sure that we don't stay at this lower level, that we actually want to bring it up just a little bit. Now in this case, I might go up 5 millimeters, and this gives me enough clearance from the ground that we can have a little bit of flex. Now in this case, I'm actually going to go up 10 millimeters, and noting that we're not really interfering with anything at this point in time. Again, this receiver is not super critical. It can go just about anywhere. It's fairly light, and its packaging is going to be dependent upon anything else that we throw in here. So once we're happy with that's location, I'm going to go ahead and say OK. And I'm going to go to Create, Mirror, and I want to mirror this component. I want to take this and I want to mirror it across the right plane and say OK, because remember we are going to be using 2. Now you can see here that we have a small gap in the middle of it, and that's okay for now. Again, we will be moving things around. We just want to make sure that we get most of the components situated where they need to be. The next thing that we're going to have to bring in is going to be the power distribution board. Now this is going to be critical because the batteries are going to plug into the power distribution board, and then all of the power going to the ESCs, or the electronic speed controllers, are going to come out of the power distribution board. It's also going to be the hub for where we plug in the camera, where we plug in the flight controller power, where we plug in the transmitter for the camera, and even the video signal in this specific case. So we want to make sure that we have this in a good location, that we have enough space above and below it, and that again, that we can access it. And again, I can't stress this enough. We're getting these in a relative location to make sure that we can account for some physical mass that we need to mount. So things are going to move around from here, but we just want to get them in roughly the right location. And for right now, I'm not too worried about the camera or the video module, because those two things are going to be very flexible in terms of their location. They don't weigh as much as some of the other components. The camera has to go in the front of it, and the video portion of it's probably going to go in the back. But the ESC is going to be the next critical component. Now there will actually be 4 of these, 1 for each motor. So their location is going to be important in terms of the overall wiring. Now again, we want to keep all the mass centered as possible. And since we're going to have 4 of these, we're going to put 2 on one side of the craft and 2 on the other. And we want to keep them out of this area because we don't want to obstruct the propeller. We want to make sure that it gets enough free, undisturbed air. So again, I'm just going to simply place it in roughly the right location. I'm going to go to Modify, Move Copy, and I want to copy this component. And I'm going to say Create Copy, and I'm simply going to move it off to the side for right now and say OK. I'm not going to worry about mirroring these to the other side like I did the battery just yet until I have a more final location. Let's go ahead and save the file so that way we can move on to our next step.